Now let's look at next type of questions of Laplace transform. And we will be solving these questions using standard formulae. And all the standard formulae are written over here for your reference. So you have to remember these formulae, okay? And the entire list is written over here. And let us begin with the first question, where f of t is given to us as cos raised to 4t. And the question is to find Laplace transform. So let us write down like this, that f of s is a Laplace of f of t. Okay, and in this case the value of f of t is cos raised to 4t. This is Laplace of cos raised to 4t. Now point that you have to understand here is we don't have a standard formula of cos raised to 4t, so we have to simplify the given function, okay, and we have to get rid of this power 4. Okay, if it would have been just cos t, we could have got the answer directly by using this formula here. Okay, but right now we have cos raised to 4t, and first we have to do is we have to simplify this, and for that I'm just going to give you one more formula. We already know by standard trigonometric formula that if we have cos square theta, that can be written as 1 plus cos 2 theta divided by 2. So we'll make use of this formula and simplify this. So let us begin. This is going to be Laplace transform of, then cos square t, I can write it as cos raised to 4t, I can write it as cos square t the whole square, right? And then this will become Laplace transform of, now this inside cos square t, I can use this formula and simplify. So it will become 1 plus cos 2t divided by 2 the whole square. So let me now just square this, and look, you will get this denominator square would be 4. And that being a constant, I can write it outside Laplace transform. Okay, so that's 1 by 4 outside. And now we will square this bracket. So the first term will be 1. That's the square of 1. Next is 2 times cos 2t plus cos square 2t. Okay, so we have expanded this. We simplified in a big way. So right now the 1 is again the standard function, and the Laplace transform is very easy to find. Then cos 2t is also a standard function. We can also use this formula and find out cos 2t, Laplace transform of cos 2t. But then now we have a cos square 2t, right? For cos square 2t, we have to simplify one more time. So let me do that. We will use this formula again, and you will get this as 1 by 4 Laplace transform of 1 plus 2 cos t as it is. And now this term will become cos square theta. The formula is 1 plus cos 2 theta by 2. So cos square 2t will be 1 plus cos 4t, isn't it? This will become double divided by 2. Okay, that's going to be the last term. And now we want to find out Laplace of this. But before that, you can simplify by taking this 2 out of the bracket. So if we do that, this f of s will become 1 by 4 outside. Then this is let's take this 2 out. Okay, so if I have to simplify this, what we will do is, let me write down a few steps here. Say this is, I can write 2 by 2 here and 2 by 2 here. So now from each term I can take this 2 common, right? So when I do that, it is going to be 1 by 2. I hope you followed that part. So now I get this is 2, the first term. Then this is 2 times cos t. This is 4 cos t. Okay, and then if I take this 2 out, this will become plus 1 plus cos 4t. Okay, and always I can club this 2 and 1. So let me finally write down this f of s is equal to 1 by 8. I forgot to write L over here. This is Laplace of. This is 2 plus 1 is 3 plus 4 cos t plus cos 4t. Okay, and now we can use the standard formula, as the type says that it is Laplace transform using standard formula. So finally I write down f of s. The final answer is going to be 1 by 8 Laplace transform of 3. The 3 is constant, and then Laplace transform of 1 is going to be 1 by s. So you'll get this as 1 by s. Then next will be 4 is a constant, so it will remain as it is. And Laplace transform of cos t is going to be cos at is s upon s square plus a square. Understand, our a is 1 right now. This is 1t. So you're going to get s divided by s square plus 1 square, which is 1, plus now Laplace transform of cos 4t will become s divided by s square plus 16. and that's your final answer. You can't really simplify more, so we will declare this as the final answer. Now this, if you see, if you can observe that all the values are written in terms of s. So this is one very simple question of type 2. This was the first question. Now we will see the second one. Now the question number 2 is also of the same type, and you have a function f of t is given to you as sine of omega t minus alpha. Okay, so with this function we have to find out Laplace transform. So step 1 will be f of s is Laplace of f of t. Okay, and there I'll write down the new value of f of t. This is going to be Laplace transform of the f of t is nothing but sine of omega t minus alpha. Okay, and now to find Laplace transform, we have all the standard formula, like we have a formula of sine at over here. We could definitely use this formula, but understand that the formula is for only sine at. So if you have like sine at minus something, if you have this, if you wouldn't have this term, okay, the answer would have been omega upon s square plus omega square would have been the answer, right, as per this formula. Okay, so you can directly use the formula if the form is exactly matching with whatever is the standard format. Okay, but that is not the case here. If you see, you will have sine of omega t minus alpha. All right, so we have to simplify this first and get it in the right form, and for that we will use the trigonometric formula. Do you know the formula of sine of a minus b? Okay, the expansion of sine of a minus b is sine a cos b minus cos a sine b. So if I use this expansion, okay, first, so you will get something like this. This will be Laplace transform of sine a. So you have this term as a and this term as b, and you have sine of a minus b, which can be solved using this formula. So you'll write this as sine of omega t cos alpha, okay, sine a cos b minus cos of omega t sine alpha. Is that correct? So we are using the formula here, and now we got it in this form. Okay, so now when we are finding Laplace transform, the Laplace transform will only work with the term with the t. So it will work on sine omega t and it will work on cos omega t, and cos alpha is going to be a constant. Okay, so we will treat it as a constant, and we will not do any Laplace transform. So cos alpha will remain as it is. So the answer cos alpha remains as it is. Now, what is the Laplace transform of sine omega t? This is comparable with sine at, right? And sine at has got a upon s square plus omega square. So sine omega t will be omega upon s square plus omega square. And then minus, once again, sine alpha being constant will remain as it is. And cos omega t will use this formula. Cos at is nothing but s upon s square plus a square. So this will become s upon s square plus omega square. And now this is the final answer of f of s. So all you have to learn here is that you have to get it in the exact same form as the standard formulae we have here. And then you can use these formulae and write down the answer of Laplace transform. Now let's see one more problem. The third question is when your f of t is square root of 1 minus sine t. Okay, and we want to find out Laplace transform once again. So f of s is Laplace of f of t. Then I'll replace f of t, which is square root of 1 minus sine t. Now we have the Laplace transform formula for 1 and sine t both, but do you see they are under this square root sign? Now the square root has to go, okay? And to get rid of a square root, we will use one standard formula we have, that whenever you have 1 minus sine theta, okay? This is the standard formula from trigonometry. We can write this as cos theta by 2 minus sine theta by 2 the whole square, okay? I hope you know the standard formula, otherwise you have to remember this. Okay, it can be easily proved also. But now I'll replace my 1 minus sine theta as this term, the bracket square. And as soon as I do that, this square root will cancel out. So let me write, this will be Laplace transform of square root of, and now we will replace 1 minus sine t. We can replace that by cos t by 2 minus sine t by 2 the whole square. This will be cos t by 2 minus sine t by 2 the whole square. So once we replace like that, okay, we have to find out the Laplace transform now. First of all, this square and root will cancel out, and you will get cos t by 2 minus sine t by 2. Okay, and the Laplace transform is going to be, now this is cos at where a is half. Okay, this will become s upon s square plus 1 by 2 square, which is 1 by 4. That's the Laplace transform of the first term, minus the Laplace transform of the second term. This is sine 80. So you'll use this formula again, and that will become a. A is half. I hope you understand that. So it is half s square plus 1 by 4. Maybe here you can do one more step and simplify this, because the denominator for both of them is same. You can write it as s square plus 1 by 4, a common denominator, and the numerator will become s minus half. Okay, and this is the answer for the Laplace transform of the third question. Let's see the fourth question now. Say f of t is given as cos 3t minus t raised to 7 plus e raised to 3t. Say if this is your function f of t and you have to find Laplace transform. Now this question is much straightforward. Okay, we have f of s as Laplace of f of t. So I'll write Laplace of f of t, where we'll put f of t value as cos 3t. We're using this function f of t here. Cos 3t minus t raised to 7 plus e raised to 3t. So the Laplace transform will be, we can find Laplace transform of each one of the term. Laplace transform of cos 3t minus Laplace transform of t raised to 7 plus Laplace transform of e raised to 3t. Okay, once you do that, the Laplace transform of cos 3t, you will use cos at formula, which is s upon s square plus a square, that is s divided by s square plus 9, minus, then you have Laplace transform of t raised to 7, where you can use this formula. Laplace transform of t raised to n is gamma n plus 1 divided by s raised to n plus 1. So this will become gamma 8 divided by s raised to 8, plus Laplace transform of e raised to 3t. So the Laplace transform will become s minus 3, and this is your final answer.